that I'm going to record in here.
Wait, we're ahead of the other class?
Yeah, it's just because we flip-flopped. We flip-flopped because of that day. So they missed out on 2 red days, so they were a little bit behind.
That's tough.
I mean, it's not really like a whole day ahead, it's just, it's split. Alright, so a triangle. Okay, we're going to talk about the properties of how we can... Are you okay?
Yeah.
Alright, so the properties of triangles. A triangle is a figure formed. I know I didn't give you enough space, so just right under this box if you want to. A figure formed by 3 segments. Joining 3 non-collinear points. Alright, so triangle classification. We can classify triangles by angles and their sides. Okay? So there are 4 different ways to classify by angles. The first one is called equiangular.
Say that again?
Equiangular.
Equiangular.
There you go. So that means you have 3 congruent angles. You guys have to make sure you're paying attention to the words that classify angles versus the words that classify the sides. So, if it's equiangular, I want you to draw a little cute triangle here.
Triangle.
Okay, just draw a triangle. And if it is equiangular, no, make sure it fits into the box here, just like mine. That means that all of my angles are equal. So make these little congruent signs there. Those arcs mean that they are all equal. Alright, then we have an acute triangle. So we have 3 acute angles. Write it smaller. And 3 acute angles. Remember, we like to use our abbreviations. So if we have a triangle, let's just draw one. What does acute mean? I need to have measures under what?
90.
Under 90, right? Because 90 is a right angle.
Right angle.
So that means that, let's say we put 80 degrees here. Okay, if all of your angles are less than 90 degrees, it is an acute triangle.
I think this is like 99.
We'll get there. Alright, if it is a right triangle, we have 1 right angle. So, how do I know if something is a right angle? If a triangle is a right angle?
It has a little dip thing.
It has like a little square there, right? Okay, that's how we can tell if it's a right angle. Sorry, if it's a right triangle, it has a right angle in it. A right angle is equal to what? 90 degrees. Alright, then we have obtuse, which means we have 1 obtuse angle. Let's go ahead and just make another triangle here. Yours may be a little better drawn than mine.
That type of triangle.
So if it's acute, that means that this angle has to be more, sorry, this obtuse, that angle has to be more than what? More than 90. You can name it whatever you want. You can name it 99. I'm going to write 120. All right. If you have at least 1 obtuse angle, then it is an obtuse triangle. Alright, you can also classify by the sides. For your sides, if it's equilateral, you have 3 congruent sides. You guys see the difference between equiangular and then equilateral?
Do the same thing.
If it's equiangular, we're talking about angles, right? Equilateral, we're talking about our sides. So that means let's draw our triangle. And if I have 3 equal sides, I'm going to have these hash marks there that just tell me that they're all the same. Those hash marks are just our way of knowing they're all the same. All right, isosceles. We have an isosceles triangle. Everyone say isosceles. Isosceles. Yes. That means you have 2 congruent sides. So let's draw a triangle, Brian. Draw your triangle. And if I have 2 congruent sides, I have 2 hash marks. And then that tells me that if one side is 5, my other side is going to be 5.
So this is only the hash marks.
The hash marks just, yeah, that's how we can recognize it.
So like, if it feels like an equilateral, it's so extra, then we just try to draw that out.
Yeah.
That's whack.
All right, scaling. Scaling means we have no congruent sides. All right, so let's draw another triangle. And this time, because none of them are the same,
You put no.
well, I'm gonna
Put nothing.
put different numbers here. So that tells me like my first side is 5, my second side is 6, my third side is 7. Those are not the same numbers. They're all different. Did I cut this down?
Yes, ma'am.
All right, now we're gonna quiz ourselves. All right, it says match a triangle description with the most specific name. Equilateral triangle, scalene triangle, obtuse triangle, equiangular, isosceles, or right. All right, all those we just noticed. All right, it says number 1, your side lengths. 2 centimeters, 3 centimeters, or 4 centimeters. So clearly, if we're talking about sides, we're looking at equilateral, isosceles, or scalene.
Scary.
Why'd you say scalene?
Because they're not equal to.
They're all different, right? So this is a scalene triangle. You will notice that I will most likely always use symbols for this unit, so you guys can too. All right, number 2, our side lengths are 3 inches, 2 inches, and 3 inches. Isosceles, right? Isosceles because I have 2 sides that are the same. So this would be an isosceles triangle. Chris, what about number 3? 4 millimeters, 4 millimeters, and 4 millimeters.
Equilateral.
Equilateral triangle, good. What time you guys go to lunch again? Technically 12:16. All right, number 4, your angle measures. So now we're looking at the ones with angles. Your angle measures are 60 degrees, 60 degrees, and 60 degrees.
Cube.
If they're all, well, okay, it would be a cube, but what's the more better answer? They're all the same angles.
Equilateral.
No, not equilateral, but
Oh, God.
equiangular.
Equiangular.
Is there an L in there?
No. Yes, ma'am.
Equal.
Okay.
There is not an L. I've been writing it wrong for years, I think.
Cat.
Equiangular. That's equiangular triangle. All right, what if my angle measures are 30, 60, 90? Sam, what do you think? Look at your notes. So you have equiangular, acute, right, or obtuse.
Can I be like,
If it has a right angle, you see that 90 degrees? It will be a right angle, right triangle.
can it not be like numbers?
I mean, it could be acute. Actually, no, it can't be acute. Your only answer there is a right triangle.
I'm so sorry, but is there such thing as a left angle?
Wait, what?
I was just asking you.
Just ask there's a left angle. All right, your angle measures, Diana, of 20 degrees, 145 degrees, and 15 degrees. That'd be equiangular, acute, right, or obtuse. Obtuse.
Yes.
She chose obtuse because if it has at least one obtuse angle, then it is going to be obtuse. All it takes is one. Chris and Brian, do you guys have this down?
Yeah.
All right, I want you guys to take 2 minutes to do the last 3 on the page. What you're going to do is you're going to have at least 2 names for the first 2. The last one, you just have 1 name. Actually, no, we'll do it together, because I don't think you guys.
I got this.
No, no.
No, the first one is a right.
All right, do you see how they have classified the sides and the angle? Do you see that? Your sides are classified by these hash marks. Your angle is classified by
Right angle.
this. Okay, so we know it's a right angle. What else is it?
Triangle.
Right and isosceles. What'd you get for the middle one, Brian?
Q.
Acute what?
Isosceles. Yeah, isosceles.
Okay, so we have our
I
sides,
got the right for the left.
right?
Yeah.
Oh, this is a tricky one.
Nah.
It's a very tricky one, but we're going to get here in a second. This is actually going to be obtuse and isosceles.
You were wrong. Wait.
Sorry, wait. Yeah, that's right. No, I'm saying like, it's isosceles because this angle here is an obtuse angle.
No.
You haven't learned that yet, but you're going to learn it in like 2 minutes. Just write it down.
So the bottom
So what you have to realize is when they when they have hash marks, that means that you need to write what classification for the sides, and when they put the angles in here, you do the same thing. For the third one, all they gave us was an angle. So what kind of triangle is this? This is a right. I don't know anything about my sides, so I'm not gonna write isosceles. Can you stop? You're talking so much more than I am. All right, look at this part. Turn the page. You guys have interior angles. Look at this picture here. Your interior angles are angles 1, 2, and 3. Do you see why they're interior?
Because they're inside.
They're inside. And we're looking at this triangle right here. Those numbers are inside, so they are interior. We're not going to really do the exterior angles for this one because it's kind of tricky, and we're going to get there eventually.
Alright.
Did I write in these notes for you guys? Okay, so I don't know what yours says because I did not say that here, but what do you guys have?
Sum of the measure of the blank angle is equal to blank.
All right, so the sum of the measure, okay, of the interior you guys can just fill in the word. The sum of the measures of the interior, is that one of your blanks? Angles is equal to 180 degrees. Is that what you're doing?
Yeah.
That part is so important, guys. If you understand that in a triangle, it equals 180 degrees, you're already halfway there. That is a really, 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 really big part of this unit. Just knowing how many degrees is inside of a triangle. All right, the corollary to the triangle sum theorem. The acute angles of a right angle. So your blank should say the acute angles of the right angle of a right triangle are complementary Alright, what that means is complementary a blank?
Yes.
Alright, what that means, complementary are two angles that add up to give us 90 degrees. It's actually quite simple. If we have a right triangle, show it as you can. If the total amount inside my triangle is 180, and it's a right triangle, that means that this angle and that angle will equal 90 degrees. But it's kind of obvious. If you do 180 minus 90, you're left with 90. So that's kind of the same as our first one that we just wrote in there.
There's just also a thing that says and angle.
So do we write 90?
So, yeah, it should equal 90 degrees. That's what I did on your paper, was I'm labeling that A and this B. So the measure of A plus B equals 90. All right, your third one, triangle exterior angle theorem. Says the measure of an exterior angle. That's your first blank, is exterior. I'm not going to write this whole thing. So your first blank is exterior. Angle of a triangle is equal to the sum of the measures of the non-adjacent interior angles. So, the measure of an exterior angle of a triangle is equal to the sum, that's your second blank, the sum of the measures of the non-adjacent interior angles. Your last blank is non-adjacent. If adjacent means side by side, what does non-adjacent mean?
No,
They're not side by side.
So smart.
So, technically, guys, if we look at angle 3, that angle measure will be the same as the two non-adjacent, so that means it's not this angle. So 1 and 2 will equal your exterior angle. What I like to do is I like to look at your linear pairs, because we've already learned that vocabulary word. All right, let's try to get through these examples when you do your practice. All right, there's how many degrees inside of a triangle? Guys, 180. I just told you, you have to know that. That is the one thing you have to know. So if they gave me the measure, of two angles, how can I find my third angle?
No, you add both angles.
And do what with it?
Then that's about,
If I need 180 degrees total, I'm going to subtract 35. I'm going to subtract 65. What are we left with for the measure of angle 1? I'm actually not going to write it that way. Hold on. Use your calculator and do not just yell out bad things. That means 35 plus 65 plus the measure of angle 1 is going to equal 180. So what did you get for the measure of angle 1? How'd you get 80?
I did 35 plus.
And then you subtracted it from 180, right? So the measure of angle 1 is 80 degrees. That means this is 80 degrees. I can figure that out. If I have two angles, I can always figure out the third angle. All right, for the second problem, the second example, they only label one angle of 53. How can I figure out what I'm missing? Do you guys notice?
The angle.
Okay, which is what? Okay, so Chris is telling us that we at least have two angles because this angle here is 90. So how can I figure out this third angle here?
Right.
Okay, you're going to add them up and then subtract from 180? Okay, you can do that. Do it. Everyone should be practicing this on their own. Huh?
37.
All right, someone check Brian. Is 37 correct?
Yes.
Diana?
Negative 37.
Because you did it backwards. You added these numbers and then you did minus 180 instead of doing 180 minus. We should never ever have a negative angle. So you should get 37 degrees.
I got 36.
Okay, double check your work. 90 plus 53. And then do 180 minus whatever you got. Did you see it? All right, look at example 3. It says find the values of x, y, and z. Do you guys see that there's basically two triangles here? I guess technically there's 3, but we're going to split these up and look at one at a time. Do you see how they're asking us for x, y, and z? We need to figure out what's the easiest to solve for. Let's look at this first part of the triangle here on the left side. And I'll highlight the second triangle. Do you guys see how the blue triangle is asking me for y and z, right? I clearly cannot start there because I have two angles to find. The yellow triangle is much easier except to find the x. Does that make sense? All right, so let's find the yellow triangle first. What will x equal? What'd you get?
76.
76 degrees. You guys agree?
Yes.
All right. So my x here is 76. I will go ahead and write that in if I were to. It's so much easier when you write it in. For letter y degrees, we can do the exterior angles, but I think it's so much easier to do our linear pairs. Our linear pairs mean I have two angles side by side. They have to equal what?
180.
180. So if I know that this angle is 76, how can I find y?
Oh, subtract 90.
Yeah, do 180 minus 76 to find y.
104.
So y is going to equal 180 minus 76, and what do you get, Chris?
104.
104, you guys agree? All right, so now I have angle y, which is 104. All right, okay, now look at your blue triangle. Your blue triangle, you already have two angles. It's easy to find the third. How can I find what z is?
Subtract.
Okay, so for z, we can do 180 minus 104 minus 21, right? And when you guys do this, you can do it however you want. You can add those up and then subtract from 180, or you can start with 180 and just work your way down. So angle Z is 55, you guys agree? Is anyone not understanding how we just found these three angles? You will see a problem like this very similar again. Does that make sense how we found X, Y, and Z?
Yeah.
Does it make sense why we started with X first? Okay, because it's impossible to start with y or z first. We only have one angle in the blue one. All right. Example 4. Find the value of x and then the measure of b. All right. This is the right triangle, right? So if this angle right here is 90, that means that these two have to equal what? They have to equal 90, right? If you do 180 minus 90, you're still stuck with 90 degrees, right? So these two angles definitely have to be added together to equal 90 degrees. So we're going to set this up. 2x plus x is equal to 90. Would you get? What'd you say? All right, so we have 3x equals 90. How do I solve? Divide by 3. So what do we get for x? 30. Good. So that's part of our answer. It's not the whole answer though. What's our next step? We need to figure out what the measure of angle B is, right? That's what my direction said. So the measure of angle B is going to be equal to 2x. But instead of x, what am I plugging in? 30. So what is the measure of angle B? 60 what? Degrees. Because when they ask you for degrees, make sure you're careful and you make sure you put the degree symbol. So the measure of angle the measure of angle B is going to be 60. Is this making sense? Okay, you guys see how
From the answer from this, where you plug it in?
Yep, just plug it in once we solve for x. All right, last one before lunch. Example 5, find the value of x. This is our exterior theorem for our exterior angles. What this says is that
I handed it off.
Oh, great. What exterior angles say is that your non-adjacent angle, so non-adjacent means that it's not touching, right? So that means this angle that's right beside 25x, I don't want that one. This angle is equal to those two angles, okay? They're equal to each other. So if I want to set this up, I'm going to set up 12x plus 11 plus 69 is going to equal what?
25x plus 2.
25x plus 2. Okay, exterior angles means that the two angles that are basically the furthest two angles from the one on the outside, they're going to equal each other. I guess I probably should have just grouped this together. I want you guys to try to solve this. Check your work with my work as you go along. With these multi-step equations, you may have a different step than I do. That's okay. But your answer should match up. I got 6. Did you guys get 6?
Yeah.
If you did not get 6, take a look at my work. Alright, for number 5, I just told you to find the value of x. You don't have to do anything else, so that's your answer. That's where we leave it. Alright, we still have about 5 more minutes before I let you go for lunch. So, We're going to work on these practice problems after lunch. Okay, we're going to work on them, then we're going to look at the key to see what our answers are. Okay? So you guys go ahead and start working on this quietly.